This next section is about world energy sources and should take 2 hours of class time. You need to identify world energy sources. You need to discuss and outline between renewable and non-renewable energy sources. You need to define the energy density of a fuel. You need to look at what are the proportions of the different sources of energy that are used around the world. And you need to discuss the advantages and disadvantages of various energy sources. First of all, identify different world energy sources. We know of coal, oil, gas, nuclear, solar, hydroelectric, wind and wave. These are the main ones that we use. There are two types of energy source. There's renewable and there is non-renewable. Renewable means that they will never run out, or at least for a very, very long time, or can be regenerated. For example, wind and sun. Non-renewable means that they will eventually run out, and then once they've been used, they cannot be reused again. For example, coal and oil. There is one fuel which lies somewhere between the two, such as biomass, because when you use the biomass, it is used up. However, it can be regenerated, it can be replaced quicker than the rate at which you use it. So that is considered renewable. What are the energy resources which are renewable and which are non-renewable? Coal is, we cannot reproduce coal, we cannot make coal, it takes millions of years. Oil is the same. These fossil fuels, natural gas included, take millions of years to produce. So we are going to use them, they will be finished, there will be none left. Nuclear also is a nuclear resource which we use up, and once nuclear energy is finished, then there is none more left. Wind energy is renewable. Solar energy is renewable. Wave energy, tidal, hydroelectric, and biomass is considered renewable because you can reproduce it quicker than our needs. Geothermal is also renewable. In this syllabus, geothermal is not mentioned very much, so it's not an important fuel as far as this syllabus is concerned. Define the energy density of a fuel. The energy density is the energy that can be obtained, the useful energy that can be obtained from a unit mass of the fuel. For example, coal has an energy density of 30 megajoules per kilogram, which means if you burn coal, 1 kilogram of coal, you are able to obtain 30 megajoules from it. And wood has an energy density of 16 megajoules per kilogram, and so on. Notice that uranium-235, from 1 kilogram of this you can obtain 70 million megajoules of energy from 1 kilogram. But these fuels, these common fuels, are similar. Wood is quite low, but nuclear is much higher than all the others. Discuss how choice of fuel is influenced by its energy density. Why would you use a particular fuel? Well, of course, the greater the energy density, the better the fuel it is, because we're able to produce much more energy. But it depends on the availability as well. In some remote parts of northern countries, in Scotland for example, they do not have access to coal burning power stations, so in very remote areas they would burn wood and they would burn peat. Of course they have low energy densities, but these are available. A little problem: 1 kilogram of water drops 100 meters. How much energy is that able to produce? Well, the energy it produces is when the potential energy is turned into kinetic energy. So what is the potential energy? mg delta H. Mass is 1 kilogram, G is roughly 10, delta H is 100. So we basically say the kinetic energy gained is equal to the potential energy lost, and this can be converted into electrical energy. What is the assumption that we make here is that all the potential energy is turning into useful kinetic energy. And of course, when you have a turbine and a generator, it will not be 100% efficient. So this is an answer for the number of, it's 1 kilogram times by 10 times by 100 meters, gives you 1 kilojoule. So basically 0.001 megajoule when 1 kilogram drops by 100 meters, which isn't very high when you compare to other fuels, but it is renewable. State the relative proportions of world use of different energy sources that are available. This was taken from 10 years ago. Roughly, globally, 40% of our energy is produced from coal, 20% from gas, 7 to 10% oil, 15-16% hydroelectric, and 17%, similar to hydroelectric, is nuclear, and the rest add up to 2% at the time. So it's a few percent higher now. But notice that coal dominates 40%. We have, so that's 40 plus 20, 60. We have 65% of the world's energy is produced by fossil fuels. Discuss the relative advantages and disadvantages of various energy sources. You need to be able to discuss, and you need to use a common sense to describe these. If you take coal, for example, what is the cost? There's a large initial cost. You need to build a power station. The energy density is quite high. The running cost is reasonable. How easy is it to transport? It has to be transported with non-specialist equipment via road or via train. How easy is it to use? Well, in the house it's quite easy to use. How reliable is it? Well, it's 100% reliable. When you want to burn it, you can get the heat from it within half an hour in the home, or within a few hours in a power station. What is the scarcity? Is it renewable? It's not scarce at the moment, but we are using it very quickly, and it's not renewable. So soon we will run out. I think within 300 or 400 years. What is the effect on the environment? For example, the coal. There's the disruption to the environment due to mining and transport use. The sulfur compounds in the atmosphere, which contribute to acid rain, and also it contributes to the greenhouse effect. For each of the fuels, you need to have some kind of description about these. What are the factors here? And you have to basically use your common sense to do that. Now, one activity you could do is work together on a working document, a Google Docs document, where you look at all these different fuels. You decide who's going to study which fuel, work out the advantages and disadvantages, looking at all these different factors.